we are still we're still in our series Golang for beginners. Today we should talk about structs, methods and interfaces, right? So structs and interfaces, these are actually types. We've been talking about data types. um we've talked about the basic ones, the booleans, the strings, the ints, integers. So right now, let's talk about structs. Let's start with structs, right? A struct in Golang is just basically a user defined type that allows to group or combine items of possibly different types into a single array, into a single type. Sorry, I said array. Yeah, I said an array because a struct is actually similar to an array, but an array is kind of like array. In an array, you can only have the same type. Like for an example, an array of type int, you can only take integers. But when it comes to a struct, you can have different things, right? Different types: int, boolean, strings, float, whatever stuff you're thinking about. So right now, if you want to create your own type, you're using a struct. For example, let us create a type person, right? For example, here, come here. We want to do a type person. A type person. Yeah. So it's gonna be a struct. So what characteristic should a person have, right? Person should have a name, which is gonna be a string, right? And the person should have maybe an age. It's gonna be an unsigned integer. Probably don't want the age cannot be negative, right? And maybe what else can the person have, right? That maybe everybody has a net worth, right? Person should have maybe a net worth, maybe a float 64, maybe a network in what currency, which is going to be like a string, basically. Yeah, that's so. Now this is your user defined type, right? You can do so many things with your own type. For example, now how do you get that your type? We just have p1 is equals to person. This person has what? A name. Just say Joseph, right? Age, let's just say 23. Net worth, because Joseph's net worth, let's just say let's just say 500,000. In what currency? Let's just say USD, right? Say USD. So now this is it, right? You have a person P1. You have a person P1 of this. You have a person P1 of Joseph, of name Joseph, age, whatever. Net worth of this float. This is a float, so you can always have like your cowboy or your cents here or whatever USD. So now you can have like, so you can always print anything you want on whatever you want. Print line, so that print line. So maybe you want to have access to the name of the person. So all you have to do is just do p1 dot name, right? So you can always have, let's just copy all this. You can always have maybe age here, p1 age. You want maybe the net worth, p1 net worth, or maybe you want the full person, right? Just get the whole p1 off, right? So if you print this, if you run this, go run main dots. Let's clear this first so you can see what we're working with. Clear. We'll go run main.go. You can see you have the name Joseph, age, net worth. Sorry, you can see the net worth. You can see, can even have the full person here, the full objects here, whatever the person, that is the person type, right, as P1. So now you know that a struct, right, you can use it to define your own type, your customize your own type, right? And your type can have different types in it. You can even have the same type, you can even have address, you can even have an address here of also string, or is he a female, of bool, you know. You can always have anything you need to have inside the person, you can always have that inside the person, right? So that is a struct for you, right? And now let's talk about methods, right? Methods are basically, okay, for here I have a definition here. Go language supports methods. Go methods are similar to Go function with one difference. You know what a function, a function, you can always go back to my previous video. A function is basically the building blocks of every programming. If you want to start writing algorithms, and start writing reusable codes, yeah, that's where functions come in, right? So basically you have to just refer back to that my video. But there's a difference between a function and a method though. A method contains a receiver argument, right? This is the most important thing you need to know about a method, right? So now the question is, what does this mean? A method is just a function tied to a type. Basically, a method is a function tied to a type. That is it. So for example, now we have we just have probably this is a function, right? From get name, right? So here you are getting, you just want to get the name. You pass in your person here. You pass in a P, which is a person here, and then you are returning the name. So if you call this, so now you can always call this, what do you call it, instead of having this name, right? You can just maybe have a get name function. This is for this function, you pass in your P1 here, right? And that is gonna get you the name of the person. Run that. You can see the name is still Joseph. Getting the name here, Joseph, because that's what this function does. This function just basically returns this name for you, right? But you can make this a method, right? You can do a P. So now this is a method, right? This is actually a method. It is no more, you're no more passing in the function, you're tying this method, you're tying this function to this type. So now whenever you need to get anything you need to get from this, type, it's already, this is the receiver, it's already including the receiver. For example, you can get the age, the address, the age, whatever. For example, let's just do a get address, right? Get address. So let's do get age now because we have an age. So you can just do get age. P dot age. And now it's meant to be an integer, right? Age is meant to be an integer. So you are doing p.age, return p.age. It's going to typecast it because age here is a unsigned int, like I told you. You can't return an unsigned int. Since you're returning an integer, you have to typecast this unsigned int to an integer. So basically we don't have this anymore. We have so let's just go back to p.name here. P1 dot name, sorry. So that's the P1. So now for the age, you can always go to the P1 dot get age, right? And then you have access to the age same way. So you run that, you can see the age is still there. 23. So basically that's you can have this is a method. It's basically a function tied to a receiver, a function tied to a type. So this is a receiver has everything embedded in this type here, right? So you can have access to it here. So now what is an interface? According to this definition, said an interface type is defined as a set of method signature. A value of an interface type can hold any value that implements those methods. So now, I know for a beginner that English might kind of be tricky, right? Just to simplify things for you, let's take this out, right? You can also an interface is kind of like a custom type too, right? Basically it's also a custom type. So now let's say you want to create humans, right? You want to create a human being. Let's just say type human interface, right? Now you have to think, what characteristic does your human have, right? Your human must, like, by the characteristics, you might liken the characteristics to methods. What kind of method does your human being is a human being supposed to have? For example, now human being should be able to talk. Human being first of all should have a name, get the name of the human being, which is going to return, which should return a string to you. We should return a string, right? Should be able to get the age of the human being, get age, basically the age. We should return maybe int, right? And then maybe calculate what it calculates, and let's just say maybe the net worth of the human being. Maybe you're calculating maybe a new amount here, any amount, calculating an amount here which is of a float 64, and using that to calculate the net worth of float 64, and then you are returning that net worth. And let's just say maybe can a human speak? What should, okay, let's just say can a human speak English? Right? Let's just say, can a human speak English? Yeah, returning a bool, right? So let's say this is you're trying to create a human, right? A human, and these are all the characteristics that your human must have, right? And what are the humans, right? We can have babies. You can, like I said, struct. You can create different types of your structs. So your struct, you can have, like, you might want to create type baby. So maybe baby speak, baby name, baby has a name, which is a string. Doesn't have an age, baby doesn't have the age, no age yet, probably no age yet. No age. Maybe you can have maybe no net worth, English, speak English. Maybe does a baby speak English? Boom. So basically this is the baby, or maybe, who knows, maybe the baby has a net worth, but let's just leave it there. Just give birth to a baby, not up to a year yet, so no age, no this thing. So maybe you have another for teenager. Like I said, struct is used to have your custom types. You can create as many types as possible, right? So you can have maybe a teenager struct, right? Same thing. Let's just have this here. Copy. Obviously, teenager has an age. Int, so just do an assign int. But it's gonna probably gonna typecast that to integer anyways. We don't really care about that. Now let's just have an adult. We can just have an adult here. We call it type adult struct. So the same thing. Age int, and then we have net worth. Obviously, every adult must have a net worth, at least, even if it's 0, but it must have a net worth. So you can have a net worth here in float 64. So yeah, basically, how do we make babies, teenagers, and adults humans, right? How do we make each of them a human being, right? In our definition of a human being must have all these methods. You must be able to answer if the human being speaks English or not. Human being must be able to calculate the net worth be able to calculate the net worth of the human being when we pass in a new amount, when we give a human being new money or new amount. We must be able to get the name and age of the human being. So as long as babies, teenagers, and adults implement these methods, then they are all human beings. So that's we know how to create a method. So it's just about tying this method to maybe something babies. That's it. As easy as that, right? Copy this out. You get the age here too. So it speaks English. So we have this method. So babies must implement this method. Also, teenagers must also implement these methods. And also, adults must implement this method. So, right, we're having, okay, this is for babies, sorry. So teenagers, you have to change this is tied to a teenager. So by tying this method to a teenager, so you have to just copy. So that's it for a teenager. Does speak English. So the name is interfering with the method, so I'm just going to leave it as English. So basically, yeah, here too, for the adults, we have A as the method, adults, right? Copy this. Yeah, and then we are good to go basically. So now we start implementing all these methods. So for babies, you might just do, all you have to do is just probably return the name of the baby here. Return baby.name. That's all. What you might want to just return the age. Does the baby have an age? No, there's no there's no age, right? No age, so you can just return You can just return 0, no age there. So because you're not going to get anything like age inside the baby. Baby doesn't have an age. So for the new amount, you might just, baby doesn't have a net worth too, so you can just return the new amount, return new amount and the baby's net worth. And then for does the baby speak English? Does the baby speak English? You might just want to say return the bool. Does it speak English? Return b dot English. This is probably a bool, yeah. So same thing for teenagers. Here. I'm just returning t dot name here. Yeah, returning here the age, teenagers age obviously. Yeah, you're returning the network. Yeah, but the teenager doesn't have a network, so you can't return the network. No network for the teenager. So what you're gonna do, just return the new amount, because obviously that would be his net worth. And then does he speak English? Yes, of course. Or no, whatever bool you're returning, just return it. C dot English. So now for the adults, right? What you returning here? Yeah, you probably return the name, of course, the name of an adult. A dot name. Return the age here. Yeah, you're calculating the network. Obviously, an adult has a network already, so you're just returning a dot net worth plus the new amount. Then you just return does it speak English or not? English. So basically, as you can see, both babies, teenagers, and adults all have methods. All have methods that implement this. All implement these methods. All these methods, right? So now let's see how this works, right? Let's Let's take this out. I don't think we need this for now here anymore. We just have baby here. Let's have a baby. We have a baby here. Baby has what? Baby has name. Baby Alice. Age. No. Baby doesn't have an age. What does the baby have again? Baby have name, and does it speak English? English. False, obviously. Does it speak? Right? Then we have 18. Obviously. Teenager. Name. Let's say name Sukwo. What again? What do we have on the teenager? We have age, and then we have English. So we have the age. Whatever the age is, let's say 16. And then we have English. True, right? Then we have adults, right? Adults, we have the name. Let's say Joseph. Age 23. Net worth. Yeah, it's a net worth here. Let's go with, let's just give myself like $1 million US. Who doesn't want to be that rich? I guess I want to be that rich anyways. So let's just assume that's my net worth anyways. And then, do I speak English? True. Speak English, yeah. So now, right? So now let's call different methods, right? We can just do, let's just do fmt print line. Let's say let's use this one for the adults. Let's just say baby. We're using this for baby. We use this for teen. We use this for adults, right? Adults. So you can always do gets. So now you can always call this method on a baby get. Just do baby dot get name, right? You can always do adults. This is teen for teen. You can always do teen dot get name. Get name. You can also do adults dot get name, right? So if you print this, obviously you're gonna get all the names. You can see baby, Alice, teen, Asukwo, right? So you can do this one after the other. You can just do this for baby, teen, dog, even for whatever, even you're doing for age. Always do the baby dot get age, right? Get age, doesn't matter. That's so you can see baby 0, teen, 16, that's the age. So now this is how you call this. Now you're calling the methods attached to each of these baby, teen, adults. They're calling their methods because get age is the method attached to it. But then what if you want to call these people as humans? Because you want to, they are humans after all, so you need to call them as humans. You can easily just for example, for a baby, right? You can see, you can just say human, like you want to call a human, right? Dots, want to get the name of the human, and which human are we looking for? You baby. It's as easy as that, right? So let's change this to name, get name, so that get name. So you realize that it's actually the same. You can just call this get name, right? You can see you're still getting the name of the baby here. That's because the baby is a human. So you can always do the same thing. So that's how interface works. Interface, as long as you implement the method specified by that interface, you automatically become the interface. As long as the type implements the method specified by that interface, the type is automatically the interface. For example, now you can have teen here. You can also have adults here, right? They are all humans, so you can always get all their names anyways, right? You can see, maybe you want to get their age, their net worth. Let's just try, it's easy. Let's just try net worth. You want to get some net worth. Let's calculate their net worth of the baby. Then you pass in the new amount the baby has. Maybe the baby got a gift of $100. Same thing here. Calculate the net worth of the teen. Maybe the teen is working hard and is getting paid maybe $500, 500 plus 50, $50 this month. Maybe the adults, calculate the adult got paid a salary of let's say the adult, right, got paid a salary of 5,000 USD. So if you're calculating the new net worths, you're probably getting something, because they're all humans. So you can always calculate their net worth, because both of them have this method. All the three of them have this method attached to be the baby, teen, adult. So that's what you use an interface for. Use an interface to actually like it says, an interface is defined as a set of method signature. A value of interface type can hold any value that implements those methods. So now whatever implements this method is a human. Be it baby, that's in simple terms. Whatever implements these methods, all these methods, that thing is a human. That type is a human. Be it baby, teenager, or adult. So basically, that is how structs, methods, and interface kind of work. They kind of work hand in hand, although you can still use one and leave the rest. But most times most times when you see these used, they're probably especially structs and methods and interfaces. They are usually used hand in hand. So maybe you go through the video you have. If you have any question, reach out to me, or maybe make some new research about it, because from here we're going to use this as a building block to go into OOP. I know, and Golang is not really, it's not fully OOP, but it does exhibit some level of OOP. So this is where we're starting from. This is where we're starting from next week, and from there we'll be going into OOP. I hope you enjoyed the class. Thank you.